So today's lesson is on indices. Okay, for this topic you will learn indices and surds. So the first one that we will cover will be indices, and then we will cover surds. Okay, so indices, I believe you all have learned indices before, especially the basic laws of indices. But in upper secondary, you will come across indices that involves multiplication, division of the same base, and also mixed bases, and how to simplify indices, changing it to the same base or common power. All right, so before we talk about indices, just to show you one application in a real life where indices is applied. So one of the application is in memory cards. Okay, for digital cameras we also have for USB. Okay, in the early stage when memory cards was invented, it was as the capacity of the memory card was 4 megabit, but as the demand increases, okay, the capacity now has increased, okay, from 4 megabit, and then there was 8 megabit. Okay, but now we don't use megabits, we use gigabytes, so it's much bigger, and it also gets bigger in the sense that it increases. So you have SD cards from 8 gigabyte to 16 gigabyte to 32 gigabytes and so on. I think now it probably goes on to 256 megabyte and so on. Okay, and do you know that memory card actually calculated using a special form that is 2 to the power n? Okay, so it uses the calculation 2 to the power n. Okay, and that's where the indices comes in. All right, so for example, when we talk about 16 gigabyte, or first let's talk about 8 gigabyte. 8 gigabyte, that's basically, how do I get 8? It will be 2 times 2 times 2. Yeah, so that would give 2 to the power 3. Okay, because the 2 is multiplied 3 times, so it will say 2 to the power 3. So same thing when you have 16 gigabyte. Okay, because it is calculated in a special form using indices 2 to the power n, so 16 is basically 2 times 2. 2 times 2, that's 4, times another 2, that's 8, times another 2. So that would be 2 to the power 4. Okay, so the n increases as the demand increases. All right, and to introduce indices, you have learned index notation. Okay, the notation that is used for indices. So in lower secondary, you have learned 4 to the power 3 is basically 4 times 4 times 4. It is multiplied 3 times, and it is written as 4 to the power 3. Okay, where 4 is the base. So when you have 4 to the power 3, this is what you call the base. Okay, in power here, okay, we call it index or power, or we also call it exponent. Exponent. Okay, there's a T there. American uses exponent, but we follow British syllabus, so we use index. And our common term that we use is power. Okay, so how 4 to the power 3 is being read? we read it as 4 to the power of 3. Alright, so as you can see, the notation that's given here, 4 or a here, alright, is what we call the base, and n, the small n here, is what you call the index, also called as power or exponent. So this n, make sure that, so the power, whenever you write the power, it has to be smaller. Okay, do not write it as like this. Okay, it has to be smaller at the top right. So here are a few examples, okay, just to show you that the n increases as you multiply with the repeated number. Okay, so in general we say that a to the power n is equals to a times a times a times a, and basically multiplied n times. Okay, so there you go. That was the introduction of indices. You need to learn the notation, and also I've given you a real life situation where indices is being used. Right, now let's move on to the next one, the laws of indices. Okay, now these formulas or the laws of indices, they are not given in the formula booklet in the examination, so you are required to memorize it. Okay, with practice, the laws of indices should be at your fingertips. So let's have a look at the first law, index 0. Okay, meaning power 0. So anything to the power 0 is equals to 1. So for example, anything, so it doesn't matter big numbers, small numbers, they are all to the power 0, it is equals to 1. So let's say 5 to the power 0. 5 to the power 0 is equals to 1. And you could also have, let's say, a fraction that says 4 over 5 to the power 0. Again, anything to the power 0 is equals to 1. Alright, so that's the first law of indices. Second law of indices, where you have a negative indices, meaning the negative power. A to the power negative n is equals to 1 over a to the power n. So for example, say I give you 4 to the power negative 3. Okay, 4 to the power negative 3. 4 to the power negative 3 using the law here is basically 1 over 4 to the power 3. And what is 4 to the power 3? Well, that would be 4 times 4 times 4. So 4 times 4 is 16. 16 times 4 is 64. So there you go. You have evaluated the indices here. 4 to the power negative 3 is basically 1 over 64. So basically for negative indices, okay, when you have a negative indices, you know that it is 1 over something. It is a reciprocal. Okay, reciprocal means 1 over something. So 4 to the power negative 3 is 1 over 4 to the power 3. Or for example, you have so second example, say you have x minus 3, the whole thing to the power minus 2. Okay, so basically that means it is 1 over the factor x minus 3 to the power 2. Once you do 1 over, the negative power now becomes positive. Okay, so let's say for example, if you have 1 over 4, 1 over 4 to make it into indices, well, 4 here is basically 1 over 2 squared. Or this can also be represented as 2 to the power minus 2. Alright, you should be able to do it vice versa. Okay, or the laws of indices in reverse. So just remember that for negative indices, so for negative power, it is basically 1 over something. Okay, and when you have done 1 over, the power becomes positive. Okay, so that's the second law of indices. The third law of indices, what you have is fractional indices. Okay, fractional indices, here it says a to the power 1 over n. Okay, so you have fraction in your power. Alright, that's what it means by fractional indices. You have fractions in your power. So a to the power 1 over n is equals to root n of a. Okay, so an example that would be, let's say, 36 to the power half. Power half basically means square root. So this is square root of 36. So what is square root of 36? It is 6. Or second example, say root 5 of 32. Okay, root 5 of 32 is basically equals to 32 to the power 1 over 5. Okay, it is also the same as 32 to the power 1 over 5, and that should give you 2. Okay, root 5 of 32 is equals to 2. When we do indices, it is also helpful if you can memorize all the numbers from 1 to 10 to the power 5. So for example, if you're given 32, automatically in your head you know that 32, you can simplify 32 to an indices of 2 to the power something. Okay, so or for example 81 is basically 3 to the power 4. Okay, or you can have 125 is 5 to the power 3. All right, with a lot of practice you'll be able to memorize these, but you could also go through and use your calculators and just to memorize at least for the first 5 powers. That would be very helpful. Okay, and these indices question in the exam normally comes in paper 1 where you cannot use calculators. All right, okay, next bit, you have a to the power m over n, which is equals to root n of a, the whole thing to the power m. All right, then you say, teacher, why is this the same? Yes, this is also the same. A to the power m over n is equals to root n of a to the power m. Okay, I'll show you why these two are the same. So here, if we simplify it using laws of indices, root n of a is basically, if you look at this indices law, root n of a is equals to a to the power 1 over n. So this is a to the power a to the power 1 over n. Then the whole thing multiplied by m, multiplied to the power m. So you will come across this later on, where you have a to the power m. Okay, if you look at multiplication, same base, a to the power m, the whole thing multiplied by n, what you do is you multiply the powers. So when you multiply the powers here, 1 over n times m, that is a to the power m over n. Okay? So same thing for this. You have root n of a to the power m. So you have a to the power m multiply to the power 1 over n. Okay, so using multiplication, same base rule, this will also give you a to the power m over n. Okay, so if I give you an example, example 1, let's say 64 to the power 3 over 2. 64 to the power 3 over 2, you can have expressed this indices in the form of 64 to the power half, and then the whole thing multiplied by power 3. So 64 power half basically means square root of 64. And what is square root of 64? It is 8. So 8 to the power 3. 8 to the power 3, that's 512. Alright. I can give you another example. Let's say we have 125. Okay, I'm going to use negative power now. Say negative power negative 1 over 3. Okay, when you have negative power, look at the second rule here. A to the power negative n equals to 1 over a to the power n. So when you have negative power, you automatically do 1 over something. So 1 over 125 to the power 1 over 3. And this basically means 1 over cube root of 125. And what is cube root of 125? That is basically 5. Okay, because 5 to the power 3 is 125. 5 times 5, 25. 25 times 5 is 125. So cube root of 125 is equals to 5. So that is for fractional indices. Alright, so you have 3 different laws where you have a fraction in your power, 1 over something, where you have m over n, but this is also the same as 1 over something, but what you do is a to the power 1 over n multiply the whole thing, multiply to the power m. Alright, and this can be expressed also in this form where you say root n of a to the power m. Alright, have a look at the example, okay, and try to relate it to the indices and the laws of indices. Alright, I think when you look at the example, it explains better. So, moving on, the next one, multiplication of the same base. Okay, we're dealing with same base. What is the base? The base is my a. This here, that's my base. Alright, so when you have indices of the same base and its multiplication, what you do is you plus the powers. Okay, always remember that when you have same base, indices of the same base, and its multiplication, you plus the powers. Alright, so an example, say you have 3 to the power 4 times 3 to the power 5. Okay, the base is 3, they are the same. It's multiplication. So this is 3 to the power 4 plus 5. So this is 3 to the power 9. Or say, for example, you have 2x to the power 5 times 3x to the power 2. Okay, so first thing what you need to do is you see the constant 2 and the constant 3. You can multiply the constant 2 times 3, so that would be 6. And have a look at the base. So this is the indices. Have a look at the base. My base is x. They are of the same base, so what you do is you add the powers. Okay, so you add the powers, become x to the power 5 plus 2, so that is 6x to the power 7. Okay, for multiplication as well, we also have this law which says a to the power m multiply the whole thing to the power n. And when you see such expression, what you do is you multiply the powers. So let's say, for example, you have b to the power 3, the whole thing to the power 10. So what this is b, you multiply the power 3 times 10, which is b to the power 30. Okay, or for example, y squared, the whole thing to the power 3. The whole thing to the power 3 means y. You multiply the power 2 times 3 is 6. So y to the power 6. And let me give you this example. Say you have negative y squared, the whole thing squared. Okay, so remember, anything you square becomes positive. So negative y squared basically means negative y squared times negative y squared. So negative and negative becomes positive. So that's positive, and y is my base here, and they are of the same base, so y to the power 2 plus 2. So you add them to become 4. Okay, so negative y squared, the whole thing to the power 2, so it is y to the power 4. Okay, next one, that's for multiplication. Same thing for division. Of the same base, what you do is, so remember that when it's multiplication, you add the powers. So when it's division, you subtract the powers. So again, must be of the same base. So my base is a. When the base are the same and you see division, what you do is you subtract the powers, m minus n. Alright, so for example, you have 7 to the power x divide by 49. Okay, 49, can you reduce this to base 7? Yes, so you say 7 to the power x divide by 7 to the power 2. They are of the same base, so what you do is you subtract the powers, x minus 2. There you go. Or second example, say I have m to the power 8. Let me give you a simple example. Yeah, okay. M to the power 8 over m squared. Okay, m to the power 8 divide. Yeah, when you have your fraction like this, it means divide. So m to the power 8 divide by m squared, they are of the same base, so what you do is subtract the powers, 8 minus 2. So that's m to the power 6. What if you have two variables? Let's say m to the power 8 n to the power 6 over m to the power 4 times n. Okay, so what happened here is that m, if you look at m, the same base, so you're going to have m 8 minus 4. Then n here of the same base, so n 6 minus 1. So your final answer is m to the power 4 n to the power 5. Okay, the next one, or the last one here, basically mixed bases. So that means that when your bases are not the same number. All right, so a to the power n times b to the power n can be written as a times b, the whole thing to the power n. And you should be able to do this vice versa when it comes to questions. So example 1, say you're given 3 to the power a times 5 to the power a. It has the same power but different base. Same power but different base. So you can write that as 3 times 5. You multiply the constant and it has the same power a. So 3 times 5, so you say 15 to the power a. Or say you have a times sorry, let's take, yeah, say p times q to the power n. This is, it can be written as p q, the whole thing to the power n. All right, you multiply the constant and then the whole thing to the power n. So for example, another one, let's say you have p squared q to the power 3 and r to the power 4. The whole thing to the power 4. Okay, the whole thing to the power 4. So this can be written as p squared to the power 4 times q cubed to the power 4, then times r to the power 4. Okay, and using your rule, multiplication rule, can you see that p squared, the whole thing to the power 4, is the same form like your multiplication here, up here, look here. Yeah, so that can be expressed as, so you multiply the powers, that becomes p to the power 8, and then q 3 times 4, so q to the power 12, and then r to the power 4. Okay, so this form, p squared q cubed r the whole thing to the power 4, is in this form, ab the whole thing to the power n. And what we did was we break it into 3 terms. Okay, I have p squared the whole thing to the power 4 times q cubed the whole thing to the power 4 times r to the power 4. And then I'm using one of the multiplication indices, laws of indices, where you could actually multiply the powers. Okay, so the last one, same thing for division. All right, when you have different bases, when it's division, you divide the constant. Okay, so for example, you have 7x over 21x. Okay, they have different base but the same power. 7 to the power x over 21 to the power x. And let me write that properly. 21 to the power x. Okay, so powers are the same. So what you can do is you divide the constant. So you can express it as 7 over 21, the whole thing to the power x. And 7 over 21, you can reduce that 1 over 3, the whole thing to the power x. And this can also be represented as, remember, using one of your fractional indices. No, I meant to say negative indices. Can you see that? 1a to the power negative n is equals to 1 over a to the power n. So 1 over 3 here, I can represent this as 3 to the power minus 1, the whole thing to the power x. So it becomes 3 to the power negative x. Okay, this is acceptable, this is acceptable, this is also acceptable. So there are different forms. Alright guys, that is basically the laws of indices. Alright, I know there are a lot of information in there, but if you need to go back, you can rewind the video, okay, or you can re-watch the video and have a look at the example and try to understand and make sure that you can work it out, vice versa. Okay guys, so thank you very much. The next bit you have is exercises. Basically you have variables for the first exercise and then you're given numbers for the next exercise. Okay, thank you.